What equations do we have? What are our basic equations?
Force equals mass times acceleration.
Okay. So, orbital motion. Orbital motion.
Then we divide it up.
So let's see, we have your force is equal to mass times acceleration. What else do we have for orbital motion?
For circular motion,
Yeah.
you have the centripetal acceleration is tangential velocity squared over a radius.
Okay.
I mean, we can go through it all. Tangential velocity is radius times. Oh, what is that? Is that
Omega.
lowercase omega?
Yeah.
Lowercase omega is
Omega
like
R equals V. Okay. That's radians per second. That's so then seconds per radians. No, radians per second. That's frequency. Okay, so that could do it.
Did we already do the?
No, wait, that's that. Okay, never mind. Sorry, what's that?
Do we do the net forces equals mass times tangential velocity squared over radius? Or do we even know that? Well, we could.
Yeah, kind of, yeah.
We do have a mass.
What about this one? V is equal to the square root of your
RW.
GR. You're the gravity or acceleration times your radius. Do you guys ever gone over that one?
Yeah, we've gone over that. He stressed it today.
He showed us today.
Okay, so your velocity, your orbital velocity, the minimum velocity required about an object is equal to the square root of the gravity. It's like the attractive acceleration between them times your radius. If we expand this out, keep this in mind. Look at this. V squared equals GR. V squared is equal to G over R.
So when our centripetal acceleration is the same as gravity.
And so that's what that force is telling you. It's telling about that acceleration.
Could we go over the force diagram in this sense?
Yes. So in this case, we have
Who draws force diagrams?
So you have your atom right here. Is it hydrogen?
No, it's a proton. Wait, no, we're focused on an electron. With the center is a proton. And the proton has electrical force which pulls the electron towards it.
So that means that like on your electron, if you look at your electron, you have a force going down. That's that force, the pull. And like all forces, force is equal to mass times acceleration. So to find that force of gravity, it's not gravity, but let's put in terms that we know, gravity, we just take your force divided by mass. We need gravity because for your orbital equation, you need the gravity of one object over another object.
And in this problem, it's saying the gravity's different?
Yeah, because your gravity is it's not talking about the electron and Earth.
Mm-hmm.
It's talking about the electron and the proton.
That's why you didn't convert F, because I started doing that.
mg?
Yeah, so just mg over m, which was just then gr.
No, this instead.
Because this force is different.
ma equals the 8.2 to negative 8 newtons.
And so you divide that by the mass of the electron to get the acceleration that is felt. From there, you can put that into your orbital equation. Because you know the radius of the radius, like the distance. They use this equation for space shuttles as well. And they go out to space. It's super simple too. It's like really rocket science.
Right, so
It is rocket
It
science.
literally, guys, this is rocket science, okay?
So you're saying in that equation right there is the same as that one?
Which one? This one? This one?
Sorry. Bottom left. Black bottom. Oh, sorry. Up. That one.
That one.
Are you saying those two are the same?
This one and that one?
Yeah.
Yeah.
Okay.
Question.
Yes.
Why did you take the inverse?
Good question. Because what this gave me, what did that give me? Oh yeah, so from here, this is your velocity, because that's V, because that's G, so velocity is equal to x over t.
Yeah.
And that gave me seconds per revolution.
Okay, I was one step off.
So, yeah, you just take the inverse of that
Yeah.
to get revolutions per second. So basically we're taking that whole thing and putting it underneath of 1 so that it flips and multiplies, and then you get from a really small number, because before it was a really small number, like 8.4 times 10 to the negative 16th
That's
seconds.
what I got. That's what I got.
Then you take that, put that underneath a 1, and then it comes up with a really big number.
Velocity equals.
Remind me what the
2 pi
R and the
over
T is
T.
again? I don't remember.
What's that?
2 pi R.
2 pi r, that's the circumference. That's the
Okay.
total distance that he has to cover for 1 revolution.
And the T is the
Time. How many seconds it takes for him to cross that 1 revolution.
So that's revolution.
Ah, it's brilliant. They can actually see that. They
Really?
need
Yeah.
that equation because. Brilliant.
Yes. Yes.